having a look at objective functions. So we've got a problem dealing with a bakery. Okay, Anna runs a bakery producing a range of continental and other breads and cakes. The bakery makes 2 types of bread. So it makes black bread and pumpernickel. Okay, here's the number of ingredients that black bread requires of rye, and here's how much rye pumpernickel needs. Black bread only needs a bit of this other kibbled rye, but pumpernickel needs more. And unfortunately we've got limited supplies of those 2 ingredients per week. So part A is basically just like constructing the feasible region. Okay, so state the variables. Okay, the bakery wants to know how many of each it can make, so we'll let B be the number of black breads, and let P be the number of pumpernickel. In terms of constraints, there's a fair few constraints here, so it'll make sense to write all of these in a table. So I'll put black bread and pumpernickel in the first row, and then up on these columns I'll put the 2 ingredients. Okay, so rye flour and kibbled rye. Okay, make a nice table out of this. Alright, so in terms of rye flour, black bread requires 400 grams per loaf, and pumpernickel uses 200 grams. In terms of kibbled rye, black bread uses 100, and pumpernickel has 300. Okay, we've also got, so we've used all that circle information. We've also got that there's maximum 50 kilos and 30 kilos of each of these per week, so this is going to total 30 kilos. Okay, and here 50 kilos. Yep, put them the wrong way around. Oops. Okay, so total supply of rye is 50 and kibbled is 30. Need to make sure all the units are the same. All of these up here are in grams. I'll need to convert these to grams as well. Okay, and 30,000 grams. So all the information in the question is being used, so I can write my constraints. So this wasn't constraints at all, this was parameters. Alright, so the constraints that we have are that the total amount of rye flour is 50,000 grams. So if we're making B lots of black bread and P lots of pumpernickel, then we need to make sure that 400 B and 200 P doesn't exceed 50,000. Okay, so it's the rye flour condition. The kibbled rye condition is that 100B plus 300P can't exceed 30,000. I've also got 2 other really basic conditions, that B can't be less than 0 and P can't be less than 0. Alright, so got all these constraints: rye flour constraint, kibbled rye constraint, and just making sure that everything's positive constraint. So I'll need to sketch these two conditions onto this set of axes, okay, using our intercepts method. Yep, so intercepts method for both of these. So I'll do it for 1 and 2. I've got my b-axis and p-axis intercepts. Okay, this is at p equals 0, this is at b equals 0. Should be pretty good at this by now. So I'm subbing p equals 0 into this top equation, imagining that there's an equal sign there. So 400b plus 0 is 50,000. So 400b plus, whoops. Okay, 50,000 divided by 400. So 125 for my p-axis intercept. Do a similar thing for p-axis. So 400 times 0 plus 200p equals 50,000. So 200p is 50,000. P is 50,000 divided by 200. 250. So that's my first constraint. Do the same thing for the second constraint. So subbing into the second equation, that middle term will become 0. You should be about this fast at solving equations by now. Right, so time to plot those constraints. So I'm going up to 300 on the b-axis. I'll make this the b-axis and this the p-axis. Okay? Doesn't matter which way you choose to do it, as long as you're consistent all the way through. So b-axis needs to go up to 300. P-axis up to about 250. Alright, so first constraint is p equals 0, b equals 125. Over here. And b equals 0, p equals 250. Right here, and we'll draw a straight line between these two. If you've got a ruler, use a ruler. And do the same thing for the second constraint. So b equals 300, p equals 100. Straight line between these two. You do a much better job than me because you're not using a computer. So both of these are less than. See over here. both are less than, so that means we're shading down, and we've got greater than 0 for both of these. So P is greater than or equal to 0, so there's a line on the P axis, there's a line on the B axis, pushing it all through. Here's the shaded region, or the region of feasibility rather. So the bakery can make any of these combinations in that shaded region. Okay. The idea of objective functions is to take that a little bit further. Okay, where we want to actually maximize some value. So in this case, we know black bread sells for $2, whereas pumpernickel sells only for $1. We want to construct an objective function to maximize revenue. Okay, so the total revenue, okay, is going to be the revenue from black bread plus the revenue from pumpernickel. Okay, so let revenue be big R. Revenue from black bread, well, black bread sells for $2 each, and we'll multiply that by how many black bread we sell, which is B. Revenue from pumpernickel, pumpernickel sells for $1 per loaf, times it by how many pumpernickels we sell, B. Okay, so our revenue is 2B plus 1P. Okay, these both should be P. Alright, so I want to graph this on that same set of axes. I have to try and find out which one of these in the feasible region will give me the maximum profit. Sorry, maximum revenue. Okay, so I've got B, P, and R, so 3 variables. I can't really graph that at all. So the way around this is to just choose a value of R. So let's choose R equals, say, 400, and see what that graph looks like. Okay, so just graphing any revenue will explain a bit more detail why this is useful once we get it up on the graph. Okay, so we're looking for a B-axis and P-axis intercept. So B-axis intercept is when P equals 0, so 400 equals 2B plus 0, 2B is 400, is 400 on 2, is 200, this one's at B equals 0, alright, so I'm going to sketch this objective function on that same set of axes. So we've got a B equals 200 and P equals 400. I should have labelled all of these graphs before I started doing anything else, so I don't get lost in the detail. Alright, so putting my objective function on, B is 200, P is 400. Between those 2 points, put a line through, and right on top of it. Alright, so every point along this line is a combination of black bread and pumpernickel that would yield $400 profit. Okay, as you can see, none of these points are within the feasible region. So the bakery is never going to actually make $400. Okay, it's not possible. So just to demonstrate how this idea works and how we're eventually going to get a solution, let's see what happens at the revenue of 300. Okay, so graph the same expression. Okay, after a b-axis and p-axis intercept. Right, so I can put my new objective function for 300 revenue, P150 and P300. Yeah, so you can see again, never going to actually make $300 revenue. Yeah, we just don't have enough ingredients to do that. But you should be able to see how, as we decrease the revenue, we're getting closer and closer to this this region of feasibility where we can actually make that combination of breads. So these two lines, the R equals 400 and R equals 300, they're both parallel. So as we continually reduce the revenue, we're going to draw more parallel lines that come closer and closer to this region of feasibility. Okay, and the first point that it's going to touch will be this corner. Okay, so we're imagining just pushing that line parallel all the way to reach that corner, and that will be where maximum profit will occur. Not max profit, max revenue. In a lot of the other problems, it'll be set up for revenue, for profit. Okay, so challenge from here is trying to find where the coordinates of that point are. Since the graph doesn't really show it very clearly, what we'll do is use our graphics calculator to find that intersection point. Okay, so we're looking for intersection of our two constraints. Intersection of those two. Okay, so finding intersection point of these two. Now we'll go to our graphics calculator and we'll try and graph these things. So from menu, scroll down to graph. All of the graphs are in terms of y equals. Okay, I can put y equals 5x. Okay, I can't type in anything with b's or p's, and I can't type in just any random equation. It always needs to be y equals. I can put in an inequality. I can put in less than or equal to. Okay, just by going type and across to y is less than or equal to. But again, it needs to be rearranged for y equals. So it's going to take a little bit of work. We'll grab this first function. Alright, so the way we graphed these ones was we had the b-axis as the vertical axis. So when we look at rearranging this, we want to get b by itself. So just like solving equations, 400b, I want to get rid of this positive 200p, so I'm going to bring it to the other side and make it negative. Okay, so you can essentially treat the less than or equal to sign like it's just an equal sign. Now I need to get rid of this 400. It's multiplied by 400, so do the opposite of that. Divide all of this by 400. Okay, and I'll be able to enter this into my calculator. Okay, so I'm essentially pretending that B is Y and P is X. Put this in here. 50,000 minus 200 X divided by 400. And draw that. It'll be a big shaded region. Might want to change my view, so shift, zoom, auto. It's graphed it and shaded it for me already. So it's going to do the same for the second equation. Okay, I need to get B by itself. So I'll bring this 300p to the other side and make it negative, and then divide through by 100. Okay, so you need to make this type a less than or equal to 1 as well, and put in that equation that you want to graph. And again, pretending that B is Y and P is X. Draw both of these. Maybe zoom out a little bit so I can see what's going on. Arrow across maybe. I should have two graphs in there. Where's my other graph? Yeah, so the auto zoom can help you here. I'm just guessing and checking what my bounds should be. But I should probably just go shift view window and set that manually, because I know what they should roughly be from my original graph. So the y-axis is from 0 to like 200. That should be down here, 0 to 200. And the x-axis between 0 and 200, so I should get a good picture here, hopefully. Yep, there we go. So I want to find where that intersection point is. And graphics calculator is pretty cool, can graph heaps of stuff. So to find the intersection point, go to Shift, G-solve, and I want the intersection. So it'll tell me exactly where it is. So x equals 70 and y equals 90. Okay, so I know the intersection point is 70, 90, and we need to remember that this is like xy, but we replaced y with b and x with p. Okay, so seems to be p equals 70 and b equals 90 is going to be where we get our maximum revenue. To find what that revenue is, remember our formula was 2b plus p, so we'll substitute in those two values. So r equals 2 times 90 plus 70, so we'll get $250 profit. Okay, and we should also probably double check that these two satisfy our constraints. Okay, so to check that they satisfy constraints, these two. These two constraints. So I'll just sub in both of these values and make sure they satisfy both constraints. So sub them into 1, so 400 times 90 plus 200 times 70 should be less than or equal to 50,000. Okay, so 36,000 plus 14,000. Hopefully this is all good. Adds together, yep, 50,000 is less than or equal to 50,000. Good. Do the same thing with number 2. 100 times 90 plus 300 times 70 should be less than or equal to 30,000. Smash through this. Get the same thing. Okay, so we can see that our solution has used literally all of the ingredients. So it was right on that corner. Right on that corner we've used all the ingredients, and we'll also be making the maximum profit of maximum revenue of 250. Okay, in some circumstances the intersection point won't be exact, so we'll get something like 60.7 and 54.1. In this case, these exact values will use all of the ingredients, but it won't make any sense because you can't make 0.7 of a loaf, so you'll need to investigate 60, 54. So rounding down both of these and checking that 60, 55 doesn't work, and also 61, 54. So checking that these three, see which ones satisfy the constraints, like on the next page. Okay, see if they satisfy constraints, and then see, so say maybe these two might satisfy the constraints, then we would substitute both of these into the revenue function and see which of them gives the maximum revenue. Okay, so I'll set you a few of those for you to practice. Get rid of all of this so that the notes can make sense as well. Yeah, obviously can't undo forever. Go away. And once you've done one or two of those, you can maybe have a look at some of your assignment as well.